Hi guys, Dr. B here. So this is topic 6.6, Introduction to Enthalpy of Reaction. So the objective for today is to calculate the heat absorbed or released by a system undergoing a chemical reaction in relationship to the amount of the reacting substance in moles, the molar enthalpy of reaction. So for all of our topics so far, 6.4, 6.5, and 6.6, we're still looking at the heat absorbed or released by a system. But now we're going to actually use a balanced reaction, and we're going to see how we can incorporate delta H into these reactions, okay? So as we've seen, main reactions lose or gain energy because the reaction is taking place. So we can say N2 plus O2 produces 2NO, and the delta H is plus 180 kilojoules per mole of reaction. Or you can say N2 plus O2 plus the 180 kilojoules produces the 2 moles of NO. Both reactions indicate that the reaction is endothermic because heat is going into it to produce it. Heat is absorbed in the course of the reaction. The reaction shows the amount of heat energy required for the reaction as it is written. 1 mole of each reactant to form 2 moles of the product. The heat can therefore be used as a conversion factor as shown below. For example, how much heat Q is required to react 2.4 moles of N2 with excess O2 to form NO, meaning that the only thing we're worried about is the N2, that's our limiting reactant. So we would use this right here to be able to create it as a conversion factor, convert to kilojoules. If 25 kilojoules of heat was absorbed, how many moles of NO were produced? Well, we still can use our relationship of moles of NO for 1 mole, the 2 moles of NO for the 180 kilojoules, and use that as a conversion factor as well to end up with our moles in our answer. So we're going to be dealing with constant pressure for these things. Delta H, enthalpy, equals the Q. All this stuff, don't worry about it. Focus on this for now. All right, so we have 2H2S plus 3O2 makes 2H2O plus 2S2O. SO2, I'm sorry. You have a delta H of negative 1,120 kilojoules per mole of reaction. If you were to react 7.25 moles of H2S with 9.3 moles of O2, how much heat would be released? Notice here, you have to look at this. Notice how we have 2 reactants present. That means, though, that you have to convert both moles to kilojoules to figure out which one is going to be the amount of heat released. Basically, of the 2, you have to determine which is your limiting reactant. Okay, so 7.25 moles of H2S negative 1,120 kilojoules per 2 moles of H2S. That just comes from the balance reaction there. This will equal approximately negative 4,060 kilojoules. We have 9.34 moles of O2. Convert that over. Negative 1,120 kilojoules. 3 moles of O2. Again, the 3 just comes from there. I end up with negative 3,490 kilojoules. So how much heat will be released? Negative 3,490 kilojoules. Wow, I cannot write right now. If you were to perform this reaction, 2H2O plus O2 makes 2H2O, and you have a negative 481.6 kilojoules per moles of reaction for the delta H. If you were to perform this reaction and you produce 92.1 kilojoules of energy, how many moles of water are also produced? So because you're producing this amount of energy, so it means it's produced, it's like leaving the system, so it's negative. So negative 92.1 kilojoules times 2 moles of water per negative 481.6 kilojoules. This equals 0.382 moles of water. All right, that's it for this topic. If you have any questions, please let me know. Thanks, guys.